diagram, just put it outside. And we know what we want. We want x here. So let's go x over the sine of 15 degrees. Let's use the sine rule. X over the sine of 15 degrees. And now I'm in a little bit of trouble because the piece of information I have is 80, and I wish I had this side, this angle. I wish I had that angle, but come on, we do have that angle. We just go 180 minus 20. Sorry, 180 minus 120 minus 15. That's 45 degrees. Super. Okay, 45 degrees. So we have x over the sine of 15, now we're putting the distance on top and the sines underneath, equals 80 over the sine of 45 degrees. So I'll just solve that with using the calculator. Okay, so popping the sine of 15 degrees up here will give you the answer. Just to be clear, the sine 15 degrees over the sine of 45 degrees. Now if I was to create a video now of this, it would be far smoother. What you're seeing is original problem solving where things can go wrong, or at least you can be a little bit slower, a little bit sloppier. Okay, that's the exact value. Now they didn't say to find it in exact form. Certainly you could write it down. That would be 40 times root 3 minus 1. The exact value. Days gone by they would have asked for it in third form because you'd be writing down the maths answer, not the engineer's answer. The engineer's answer is 29.29, because if you're cutting a flagpole you're only going to be able to cut it to so much accuracy anyway. Okay, 29.28 meters. Okay, so it's a big 29 meters. That's a huge flag up on top of the building because it's in meters. Okay, moving on to question 12. So let's fill in this angle here. Is 117. Okay, you can try to practice doing them if you want it, just to save time. You're going to be subtracting from 180. So the 6 gets subtracted from 7 to give 1, and the 3 gets subtracted from 10 to give 7. So because of the carrying that's going on here, you're subtracting from 7. And then 3 from 10, it would have been 7 because the gift has been given of 10 units. That's 117 degrees, and therefore we know this is 25 degrees exactly. Now time to figure out what they're asking us. Calculate the length AB. Okay, we'll call it X. And what we do is we'd like to have, if we have this, then we'll have X. So let's get this first. Let's get Y. Now we know that Y is opposite this, and we know that 25 is opposite this. So we're using the sine rule. We can write that the Y opposite the sine of 38 degrees equals distance on top, 25 opposite the sine of 25 degrees. Okay, so, and I'm just going to show you one other trick, and that is not to bother with the is to go straight all the way out to the answer, to the very final answer. So this is sine of 25 degrees. So what are we going to do with that Y? We're going to multiply it by the sine of 63 in order. You multiply by the sine to get the opposite. Okay, so I'll multiply that by the sine of 63. So X equals 25 times the sine of 38 degrees times the sine of 63 degrees all over what does that say? The sine of 38 degrees, yeah, all over the sine of 25 degrees. Now, it's probably, apart from putting that in the calculator, it's probably worth looking and trying to come to terms with this. This times the sine of this, that kind of makes sense, just like what you're doing here, this times, no it doesn't, well that times the sine of that, y over sine of 38 equals 25 over sine of 25. That times the sine of that times the sine of that. That's interesting if you look at it. So we're kind of going, let's redraw this. So if you only had this, because if you want to learn this, because this could come up as an identity question. Okay, let's start using small letters for sides. Okay. We're trying to, this is the most important part of the problem. Not the filling it into the calculator. It's the looking back and seeing what we really learned. So what we learned is if you have an angle A and an opposite side A and an angle B, and you're trying to get this and you have an angle C, then here's the story. You do that times the sine of that times the sine of that divided by the sine of that. Now that's something we may remember then later on, but we can also have some fun with construction. And you can take out your, here's a challenge for you, a proper challenge for you now then. So construct like the following. Now I am using standard angles. I'll come in here and I want a working line is so important in a situation like this, just to keep my drawing, because this is now construction. I'm looking to verify it at the most basic concrete level, because let's face it, what I've just written down there is quite abstract. So if we're gonna explore and enjoy our maths and take, I know we've all plenty of time in our hands these days, so we would be going angle A, B, C, get X from this. So first of all, I know that this is 30 degrees. I know that this is 15 degrees. And I know that this is 45 degrees. So let's see how close, and I could have done it even better. Let's see how close our measurements come out. So I'll call that 8.7. So what I'm learning is what this length should be is 8.7 times the sine of 30, which brings a 2 downstairs, the sine of 45, which puts a root 2 downstairs, and that's multiplying on the top by sine of 45, and divide by the sine of 15 degrees. Okay, and just in case you don't believe me about those, actually I'm beginning to worry about that myself. No, but it's right, sine of 30 and sine of 45 is that. But in case you don't believe me, and in case we missed that point, sure, we could use the calculator for everything anyway. So we could say sine of 30 times the sine of 45 all over the sine of 15, boom, 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 okay, sine of 15 degrees should be equal to this height. Okay, blah, 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 that's worth 11.88. So you come along here, and we're gone above 11.5. We didn't make that meet up very nicely up there, but now I will. Promise I'm not going to be biased now, and neither did I make them join here. The next version of this video will have be more polished, but if I went back doing videos again, I would never get anything done. And there we are, we're creeping up towards 12, so it's certainly been verified to within the margin of error that you'd expect from construction. Okay, so we've learned more, and we'd be prepared if an exam question came up, we'd already know that identity. That, just to draw it one more time, so saying, how do you go from there over to there? You multiply it by the sine of that times the sine of that, and you divide it by the sine of that. Amazing, absolutely amazing stuff. Okay, so we'll actually calculate this, which we won't be able to check because the drawing isn't probably to scale or anything like what's 25 mean, but we can certainly calculate it. And now I won't even have to look at the drawing because I've processed it. Okay, so we can go fraction bar 25. So I already know this formula for this particular geometry situation. You could call it a theorem now if you want. This, because you've proven it, the sine of 38 times the sine of 63 divided by the sine of 25, divided by the sine of 25. Okay, so the answer is, and we'll just make sure that passes the common sense test, that it makes sense within the values. This is 25 and this is a bit bigger, 32.45. Oops, was I off? Yeah, it's a no. Okay, that's question 12 done. Now we're going to have to do a little bit of our own constructing. So we might start with just a little bit of a small sketch before we construct it in a bigger way that will give us room to navigate within. Okay, so we have two vertical buildings, A and B, stand 100 meters apart. Okay, so without loss of generality, okay, we'll start constructing it. Put you down, bump there, won't be getting my money back. The angle of elevation of the top of building B from the top of building A is 20 degrees. Okay, the angle of elevation of the top of building B from A. So B is higher, so we'll put B here. And let's just very roughly, I know this is 30 degrees, so let's work off less than 30 degrees. We'll call that 20 degrees, just roughly, it doesn't have to be correct. And we'll make this building A. It's just within the ballpark. Now I said in the last earlier set of questions when you're dealing with simple triangles that you don't really care about getting the scale right and roughly the values right, but here it's helpful because the situations are much more complicated. This is a trapezium. The situations are more complicated. You have rectangles and squares and triangles inside and triangles and that, and you want to be able to check. You don't have the very, very simple rule that the angle opposite. See, if in an ordinary triangle you can just say this side, if this is the biggest angle, this is the biggest side, and so on, and you have that order and that common sense you can build in. We don't have that here unless we use sensible drawings. So we know that this is 100 meters, and then we know that this, if we do this construction, we know that this is 100 meters. So furthermore, the angle of elevation of the top of building A from the base of building B is 50 degrees. Now that doesn't look anything like 50 degrees, but that's okay. Find the height of building B, correct to 2 decimal places. So with 50 degrees here and 100 here, we know this height is 100 times the sine of 50. Now that's so important that you know your right angle triangle, you know your SOHCAHTOA, and you can apply it directly, okay? That you can apply that the opposite equals the hypotenuse times the sine of the angle. Okay? No, you know what, I must have made a mistake. That was tan I should have used. Just as well I spelt it out. So the opposite is equal to the opposite is equal to the adjacent times the tan, you see, of the angle, the adjacent A. Because the tan of an angle is equal to opposite over adjacent. Okay, so So to go from here to here, you multiply by tan. 100 times the tan of 50. It'll be slightly bigger than 100. $119.18. Okay, so find the height of building B, so the entire height. So that means to here is also 119.18, and this is real true problem solving. And then to go, we're going to use tan again. There's been a lot of tan used here, so we're going to use 100 tan 20, which I might just come in here and edit that 5 to a 2. Okay, and I get 36.40. Just add them together then. So add on 119.119.18. Okay, so the answer is 155.58 meters. And we're not finished. We're only starting, because we want to throw that away now and come to appreciate the maths that we've just learned. So you've got a height. We can just represent it as a line segment and another line segment, and you had angle A and angle B, and you just had this length here, which we'll call L for length. Okay, so what we did is we got this value as L tan of B, and we got this value here, which matches, by the way, this bit here, and we got this value here as L tan A. So we actually ended up, and it's much more beautiful and insightful to do it this way, so we ended up adding them together, which had L in common. So you basically had the two tans added together.